Hi guys, in this lecture we're going to talk about graphical summaries of data, also known as data visualization. Now it's important to note that this lecture is going to only deal with graphical summaries of univariate data. And if you recall, univariate data means we're dealing with one single variable at a time. There are other graphical summaries for bivariate and multivariate data, which will not be covered in this lecture. Okay, so I'm going to split this lecture up into essentially two main branches and focus on the data visualizations that I think are important for us. First off, the first group we're going to deal with separately is categorical variables. So remember, these are non-numerical variables. We discussed this in a previous lecture. Things like sex, political affiliation, your major, these are all examples of categorical variables. Okay, so there's different ways of visually representing this type of variable than numerical variables. And I'm going to just very briefly talk about these. There's not many here that I want to talk about, and you've probably heard of most of them already. So just let's briefly go over some of these. First off, this may not be considered a graph, but a table is incredibly useful when dealing with summarizing this type of variable, specifically a frequency distribution table or a relative frequency distribution table. So what is this? It's much easier to show you an example of this than to actually try to describe it. It's exactly what the name suggests. We're going to list out all the levels of our categorical variable and then literally count or tally up how many observations at each level. Okay, so for example, I had a little data set where n was 100 and it was pertaining to iris species. So after observing the data, I realized there were these three levels: setosa, versicolor, and virginica. So I listed them out. Okay. Then I went through the data, and usually you do this with the help of software, but it's also easy enough to do manually if n is small enough. And I literally counted 33 setosas, 36 versicolors, and 31 virginicas. So that would be an example of a frequency distribution table. Now I could take this one step further and create what's called a relative frequency table. And what that will do is it will take the actual frequencies and convert them to proportions. And how do we do that? Very simply. First we need the frequencies, but then we can take each of the frequencies and divide by n. In this case, n was a nice and clean 100. You can count this up and see that the sum of these three levels was 100. So it was an easy number to compute proportions for. But so be careful, whatever n is what you're dividing by. So here we end up with 33%, 36%, and 31%. Okay, here I've obviously expressed them as a decimal form, but you can also express them as a percentage. Okay, so what are some graphs that we can now create off of this type of table? Okay, so to get a little bit more visual than just these tables, we're going to just very briefly go over these three very common but very useful types of graphs. Okay, actually there's two fundamental ones, and I'm underlining them now. And then there is variations, and here's just an example of a variation. So pie charts and bar charts. Pie charts are great. Everyone has seen these. They're not difficult to create. What they're great for is showing a relative representation of each slice. So when I look at these slices, I can very quickly see that there was about an equal amount of the three levels. In this case, it has to do with those same iris species. Okay? Where does a pie chart start losing its favor to bar charts? When you have a lot of levels, I would argue. So for example, if our categorical variable was something like country of origin, and there were over 200 choices, and it was a rather large data set, so we maybe had representation of every country, then all of a sudden you're going to end up with a lot of tiny slices, and it's going to be illegible. Okay? So there, in that case, you could argue a bar chart will be useful. So what a bar chart will do, it will either show the frequency or relative frequency on the y-axis. So you should always check what the y-axis is labeled. In this case, clearly this is frequency, even though there's no label. And then across the horizontal or x-axis, you're going to see all the levels. You may or may not see a gap between each of the bars. Whether you do or not, you should remember that a bar chart, at least in the horizontal axis, does not have any order. So it's quite arbitrary which of these came first, second, and third. I could reorder these and it would not change anything. You should not read into that at all. It's only the height of the bar that I'm interested in. Okay? Now, pie chart shows you a little bit more as far as a real quick snapshot of the relative differences between the levels as compared to the bar chart. But the bar chart has that advantage that it can handle more levels. Ideally, both of these could be useful. And then just a quick mention, there are variations of these guys. There are donut charts and stacked bar charts, etc., etc. So you've probably seen some of these, and there's a lot of them, and there's a variety, and they're all pretty easy to interpret, but they're all based on this fundamental approach of pie charts and bar charts, but sometimes trying to pack in more information. So just be aware of these. Okay? Now we could move on to numerical variables. And for this, I'm going to pause and create a new video. So this will be part 2 of graphical summaries of data. We'll continue from here.